Today we'll be going over a Rust program that builds a simple RESTful API using the Actix-Web framework. Start by creating a new Rust project. Before we dive into the code, let's quickly look at the dependencies we've declared in our cargo.toml file. Actix-Web library is the core of our web framework. The CRUD library, which is used for serializing and deserializing data, like converting our user structs to and from JSON. The derive feature part allows us to easily derive serialization and deserialization implementations for our structs. CRUD JSON library provides support for working with JSON data specifically within the CRUD ecosystem. These dependencies are essential for building our RESTful API using Actix-Web. Now let's start by looking at the imports we have at the beginning of our code. We're bringing in a bunch of things from the Actix-Web library for building web applications. Things like web for handling web requests, app for building our application, HTTP response for sending responses back to the client, HTTP server for creating the actual server, and responder for anything that can be turned into an HTTP response. Then we have CRUD, which allows us to easily serialize and deserialize our data, which in this case will be JSON. Finally, we have mutex, which is a type from Rust standard library that allows us to safely share data between multiple parts of our program. Alright, now let's look at the struct definitions. This defines a struct called user, which will hold information about our users. It has three fields: ID, which is a U32, unsigned 32-bit integer; name, which is a string; and email, which is also a string. We use the serialize and deserialize traits from CRUD to tell Actix-Web how to turn these structs into JSON and vice versa when sending and receiving data over the web. The clone trait allows us to easily create copies of our user structs. This struct represents the application state that we'll be sharing across different parts of our application. Users. This field holds a vector of user structs. We wrap it in a mutex to ensure thread safety. Since multiple parts of our application might try to access or modify the list of users concurrently, the mutex prevents data races and ensures that only one part can access and modify the list at a time. Next ID. This field stores the next available ID to be assigned to a new user. It's also wrapped in a mutex for thread safety, as multiple requests might try to create new users concurrently. This appState struct is then used throughout our application to access and manage the shared data. Now let's move on to the main function. This is where our program starts executing. The Actix-Web main macro tells Actix-Web that this is the async entry point for our application. Inside the main function, we first initialize our application state. This state holds information that will be shared across different parts of our application. In this case, we have a vector of users and an integer to keep track of the next user ID. We wrap both of these in a mutex to ensure thread safety, since multiple parts of our program might try to access and modify this data at the same time. Then we create a new HTTP server by calling HTTP server new function. This creates a new server that will listen for incoming HTTP requests. We pass in a closure, which is a block of code that will be executed when the server is built. Inside the closure, we create a new application using appNew function. We set up the app data using appData function by cloning our app state and making it available to all handlers in our application. Next, we define three routes for our application using the route method. The first route is for the path /, which is the root of our website. It's a GET request that is handled by the index function. The second route is for the path/users, which is also a GET request and is handled by the getUsers function. The third route is for the same path/users, but it's a POST request and is handled by the createUser function. After defining the routes, we call bind to specify the address that the server will listen on. The server will listen on the local port 8080. Finally, we call run to start the server and await for the server to finish running. This line will block the main thread until the server is stopped. Now let's look at the index function. This function is very simple. It just returns a string literal, welcome to the Rust REST API. This string will be sent back to the client as the response to the request to the root path. Next, let's examine the getUsers function. This function is responsible for handling GET requests to the user's path. It takes a parameter data, which is an instance of appState. This gives us access to the shared application state, including the vector of users. Inside the function, we first acquire a lock on the user's mutex. This ensures that only one part of the program can access and modify the user's vector at a time, preventing race conditions. Then, we create an HTTP response with a status code of OK. We use the JSON method to convert the vector of users into JSON format and send it back to the client. Finally, let's take a look at the createUser function. This function handles post requests to the user's path. It takes two parameters: data, which gives us access to the application state, and user, which is an instance of user. This means that the user data is expected to be sent to the server in JSON format, and Actix-Web will automatically deserialize it into a user struct for us. Inside the function, we acquire locks on both the user's mutex and the nextID mutex to ensure thread safety. Then, we create a new user struct using the data from the request. We assign the next available ID to the ID field and copy the name and email from the received user struct. Next, we increment the next ID for the next user. We then push the newly created user into the vector of users. Finally, we create an HTTP response with a status code of created to indicate that a new user has been successfully created. We use JSON to send the created user back to the client in JSON format. And that's it. This is a basic example of how to build a RESTful API with Rust and Actix-Web. This code demonstrates how to handle GET and POST requests, manage application state, and interact with clients using JSON. It is time to test the server. Run the server with cargo run. Visit the local port address specified in the main function in your browser, or use a tool like Postman to test. First, let me show you in the browser. As we can see, the root route displays the message, "Welcome to the REST API." If we navigate to the user's route, it will display the list of users in JSON format. Now let me show this in Postman. Similarly, the root route displays the message, "Welcome to the REST API." If we enter the user's route, we can see two default users we have added in the app state. And if we try to add the user with POST request, by sending the user data in JSON body, we get the status code of 201 created and a created user JSON in response. Now if we get the users again, we will get 3 users including Charlie we just added. If you enjoyed this tutorial, you will definitely love to watch other quick coding challenges on this channel. Let me know what projects you'd like to see next. See you in the next video.